Okay, Algebra 1, second to last lesson of the year, okay? All right, so we're going to be working on finding the greatest common factor. So I'm going to do my best to explain this, all right? So there's a couple of ways, different approaches you can take. I'm going to use one approach for these and for these, and then for the rest of them, it's still you're doing the same thing. It just looks a little bit different. Okay, so to find the greatest common factor between 28 and 42. So the most guaranteed way to make sure you find the greatest common factor is to, first of all, we want to break down 28 into its prime factorization. So if we take 28, that would be, if we start breaking it down, all right, so that's 2 times 14, okay? All right, well, 14 can be further broken down, so I'm gonna break it down. So it'll be 2 times, and then 14 can be broken down to 2 times 7. Okay, so now we've broken it down, we've broken this down to its prime factors. Okay, so we've got 2 times 2 times 7. All right, now let's do the same thing with 42. Okay, so 42 can be broken down to, let's see, 2 times 21. Okay, now 21 can further be broken down to 2 times 3 times 7. And now we have all prime numbers. All right, so what we're going to do is we're going to compare our common factors here. Okay, so now this is where I need you to kind of focus and pay attention. Okay, so how many 2's do these have in common? Well, 42 in its prime factors only has 1. 2 is only listed 1 time. Okay, so we're focusing on comparing this and this. All right, so check it out. 42 only has 1 2, and 28 has 2 2's. Okay, so we can only say, we can't say that there's 2 2's that are in common because 42 only has 1 2. All right, but we can say that they at least have one 2 that's in common, because 28 has at least 1 2, and 42 has only 1 2. So we're going to pull out 1 2 there. Okay. All right. Now they do not share. Over here we have a 3. 42 has a 3. 28 does not have a 3. So we can't pull a 3 out. And then notice that in both prime factorizations, we have 7 listed once. So we can pull out 1 7. Okay, because they share 1 7. Okay, so we're gonna multiply these together, and that is our greatest common factor. Okay, let's try it with these here. So 72, that can be broken down to, and basically, you know, we'll just take that. It'd be 2 times 36. Okay, and then that can be further broken down to 2 times 3 times 12, right? Because 3 times 12 is 36. And then that can be further broken down to 2 times 3 times 3 times 4, right? Okay, so what we did is we broke down the 36 into 3 times 12. Then we took 12 and broke it down into 3 times 4. And then we can further break down the 4, so it'd be 2 times 3 times 3 times 2 times 2. So we're just breaking down everything that we can. All right, so let's just make sure. This we give it 2 times 3 gives us 6. 6 times 3 gives us 18. 18 times 2 gives us 36, and 36 times 2 gives us 72. All right, so I'm going to rewrite this. I'm going to put all of my 2's together. So 2 times 2 times 2 times 3 times 3. Okay. All right, so we've broken 72 down to its prime factors. All right, now let's do the same thing with 90. All right, so 90 can be broken down to 2 times 45. 45 can be broken down to 2 times 5 times 9. And then that can be further broken down to 2 times 5 times 3 times 3. All right, and now that's into its prime factorization. So we're going to compare just the prime factorizations. Okay, now notice that over here, 72, we have 2 listed as a factor 3 times. But over here, we only see it once. So how many 2's can we pull out and say, how many 2's do these share in common? Well, it can't be more than 1 because 90 only has 1 2. Okay, so it's actually, we're going to take 2. So we're going to pull a 2 out. Okay, now let's look at 5. Is 5 a common factor between these? No, because we only see 5 listed in the prime factorization of 90. We don't see 5 over here at all. Okay, and how many times do we see 3? Well, we have 3 listed twice over here and listed twice over here, so that means we're going to be able to pull out 2 3's. All right, so this is the same thing as saying 2 times 9. Okay, 3 times 3 is 9. So that means our greatest, so we're going to multiply these together, and it's going to be 18. That's going to be our greatest common factor. Okay. All right. Okay, so now working with variables. All right, so if we break these down into their, so that's x times y times y times y. And over here we have x times x times x times x, that's x to the 4th, times y. Same thing. I'm going to do it this way, and then I'm going to show you the other way. All right. So remember, we can't take more than the least number of times that this is listed. So if we're going to compare our x variables, x, we only have 2 x's over here, we have 4 over here. So how many can we take out that are in common? Okay, we can only take out 2 because there's only 2 over here. We can't take out, they don't share 3 x's in common, okay, because this term over here only has 2. All right, so that's going to be x squared, so x times x. All right, now compare our y variables. All right, how many y variables do you think are in common between these two terms? That's right, only 1, because there's only 1 y over here. Okay, so if you don't want to have to worry about going through all that, if you just look, okay, I know that I've got x squared and x to the 4th. Okay, well, I'm going to choose the lesser of the 2 as part of my greatest common factor. So I've got x squared, x to the 4th, so x squared is going to be part of my greatest common factor. Over here I've got y to the 3rd and y to the 1st. Again, I'm going to choose the lesser to be my greatest common factor. And so what we have, we've got x squared times y, and that's our greatest common factor. All right, a couple more. All right, now don't let this negative throw you off here. All right, so now we're combining, we're mixing, we're taking a numerical value and variables here. Okay, well, first of all, if you look at the variables, there's not going to be a variable in the greatest common factor because this term over here has an a variable, this term over here has a b variable, so they're not going to have anything in common as far as the variables go. But there is going to be a greatest common factor with the numerical values. So let's go ahead and list out our factors here. So we've got 24 has that can break down to 2 times 12. Okay, and then 12 can be broken down to 2. Okay, so let's break down 12. 2 times 6. And then this is going to be broken down to 2 times 2 times, now let's break down 6 to 2 times 3. Okay? All right. Now let's take negative 18. All right, so now follow me here, okay? I'm going to treat this just like if it were positive, all right? Because ultimately in the end, to get a negative number, you're going to have one positive times one negative. All right, so I'll show you what I mean by that. All right, so 18 is broken down to 2 times 9, and then that's further broken down to 2 times 3 times 3. Okay? All right, so let's just let's look and see what we have in common then. All right, so we've got over here we have 3 2's, and over here we have 1 2. So how many 2's can we pull out? Well, we'll pull out 1. There's only 1 2 that they share in common. All right. Remember, we can't say, oh, well, they have 2 2's. 2 2's. They have 2 2's. They have 2 2's. Because over here, it wouldn't be true. 18 does not have 2 twice. It only has it once. So we can only take out the least number that you see it listed in any one term. So 2 times, all right, now here we have a 3 and 2 3's over here, so it's going to be 3. So our greatest common factor then is 6. Okay? All right. So when you have these negatives, you can just treat it just like it's a positive, all right? Because if 6 is a factor of 18, then that means, so if we say, well, one of the factors is 6, well, then the other is what? Negative 3, all right? So we can use that positive as the common point between them. But so if you'll just the easy rule of thumb is just treat this just like it's positive, and then find the least common denominator. All right, so now let's look at these. Last one. So we have this is called a trinomial. All right, so it's a polynomial with 3 terms. Here's a term here, here's a term here, and here's a term here. So what we're going to do, I'm actually doing, this is the last problem in your lesson. So if you can just kind of stick with me here, then you'll see the answer to this problem. All right, but I want you to don't just take the easy way and just give me the answer. I want you to figure this out. All right, so we're gonna start off by just worrying about our coefficients, 16, 32, and negative 48, which I'm just going to treat it just like 48. All right, so 16, 32, and 48. So let's figure out what would be the greatest common factor between these. All right, now if we can go through this whole thing that we've been doing, we list out the prime factors, but if you'll think about it, well, let's just go ahead and do it. Let's just go ahead and do it. All right, so 16, that breaks down to 2 times 8, which further breaks down to 2 times 2 times 4, right? So the 8 broke down to 2 times 4. And that breaks down to 2 times 2 times 2 times 2. All right, so there's our prime factorization of 16. All right, how about 32? Now, I'm going to bring this down just a little bit further, give me a little bit more room here. All right, so 32 breaks down to 2 times 16. Well, that further breaks down to 2 times 8. So we broke 16 down to 2 times 8. Well, that breaks down to 2 times 2 times, we're going to break this 8 down to 2 times 4. And then we're going to break that 4 down. So 2 times 2 times 2 times 2 times 2. All right, so this is the prime factorization for 32. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. All right, now let's do the same thing for 48. So 48 breaks down, put my equal sign up here too. 48 breaks down to 2 times 24. All right, so that breaks down to 2 times 12. That breaks down to 2 times 2 times, okay, now let's break down the 12 to 2 times 6. And then this breaks down to 2 times 2 times 2 times 2 times 3. We break that 6 down to 2 times 3. So you following what I did there? I broke the 24 down to 2 times 12, broke the 12 down to 2 times 6, and broke the 6 down to 2 times 3. And everything else is just kind of, we're continuing to include those. And then this is our prime factorization. Okay, so 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 3 is 48. All right, so now, is 3 gonna be a part of the greatest common factor? No, it's not, because we only see a 3 in one of them. Remember, it has to be present in all of them. All right, so we see here that 2 is definitely going to be a part, but 2 is going to be listed how many times? Here it's listed 4 times, here it's listed 4 times, here it's listed 5 times, okay? So we can only take, right? So it wouldn't be true to say, oh, okay, well, they share five 2's in common, because there's 5 2's right here, 1, 2, 3, 4, 5. But 48 only has it 4 times, and 16 only has 4. So how many times are we going to is 2 going to be included in our greatest common factor? 4. So it's going to be, our greatest common factor is going to be 2 times 2 times 2 times 2, which happens to be 16. Okay, now I wanted to show you that you may have already just been able to look at it and go, okay, well, 16 is a factor of 32, and 16 is also a factor of 48. So 16 is the greatest common factor. All right, so we're going to pull out, so we're going to say that 16 is part of our greatest common factor. Now we have to deal with our variables. Okay, so remember what we said? Okay, so remember what we said? We said that we can only take the least number. We can only take the least number of times that we see a listed here, which is a squared. So it's going to be a squared. Okay, so we got our a's taken care of. And then we have b to the 4th, b to the 5th, and b to the 6th. And we're going to take b to the 4th. All right, so that's our greatest common factor. Okay, so, oh man, I wish I could teach this to you in person. I know this is not the easiest way to learn this. But I wish I could be there to take your questions. But you know what? We're finishing out the year here. You guys will get more practice in Algebra 2 next year for sure. And I hope this is a help to you, okay? All right, you guys take care.